Okay, so we're going to graph the polar curve r equals 2 cos theta, and we have already written out a table of values, theta going from 0 to pi, picking convenient values of theta, and the corresponding r value. So we're just going to start plotting, and of course you can see that I have already written these lines corresponding to the values of theta, which will just aid us in sketching this. You don't need to draw these lines. You can kind of see where they are or just kind of estimate about where they are, but this will just help us at least get used to what's going on. So we're starting at the point theta equals 0 and r is equal to 2. So theta equals 0 corresponds to the x-axis, which is the polar axis, and r equals 2 is a distance 2 away from the origin, right? So it's that point right there. And the next point is corresponding to theta is equal to pi over 6. So that's, rotating in the counterclockwise direction. That's our first angle measure we have drawn here. And r is equal to square root 3 there. Square root 3 is somewhere between 1 and 2, closer to 2. So we'll just kind of estimate it to be about right here, right? And so we're going to continuously connect this initial point 0, 2 to the point pi over 6 square root 3 as best as we can. And then the next point is pi over 4 square root 2. So we're going to be on the pi over 4 line, and r is just equal to square root 2. Again, somewhere between 1 and 2, a little bit smaller than square root 3. Estimate it's about right here. And continuously connect these points. Next, we have pi over 3. R is equal to 1. So about right here. And then connect these points. And then we have pi over 2. So pi over 2 corresponds to the y-axis, right? The positive portion. And at that angle, r is equal to 0. So we're at a distance 0 from the origin, and so that's the origin, right? So plot that point, and then we continuously connect those, right, as best as we can. And here's where things start to get a little bit trickier. We notice that from pi over 2 to pi, we have negative values of r. And so there's a couple ways you could do this. You could start by just converting these so that you have a positive r, converting these values so you have a positive r. But instead, we're going to just plot the points as if r were positive and then just reflect over the lines that you see are written here. So, yellow corresponding to yellow, green to green, right? So at 2 pi over 3, r is equal to negative 1. So we'll plot 1 2 pi over 3, right? So that'll be, if we had a positive, r value would be somewhere around there, right? And then just reflected over that that line on the other side of the origin is our actual point, just right there, right? And then connect those points like that, right? And then same thing going forward, right? So the point 3 pi over 4 negative square root 2 is, we're first going to draw or plot 3 pi over 4 positive square root 2, which is somewhere like right here. And then reflected over the line there, reflected across the origin, about the point right there, and connect these. And then 5 pi over 6 negative square root 3, again, just plotting 5 pi over 6 square root 3, somewhere right there, reflected over that line, over the origin. It's about right there. Connect those. And then our final point is pi negative 2. So first plotting pi 2, right, we're on this kind of negative portion of the x-axis. That corresponds to theta equals pi. And then r equals 2, positive 2, would be somewhere like right here, right? So then reflected over the origin, that is corresponds to this point. That was our initial starting point, 0, 2, right? Just like that. And you see that it looks like a circle, or a poorly drawn circle anyways. And we'll verify that by finding the Cartesian equation for the curve, right? So these points over here, I'll just mark them just so we know exactly what we're talking about, right? This point here with the x is our 1 2 pi over 3, right? And then the next one is our square root 2 3 pi over 4, right? And then here that's our positive square root 3 5 pi over 6. And this point here would be the pi 2, right? So you see those points are not actually on the graph. We're just using those to aid us in graphing this.